Well, hello there, Math 1 students. Let's get started on our Unit 3 review. A couple reminders when you're using this video. Remember that if you're just copying down what I do after you see me do it, that you're going to be learning how to copy down. And that's going to have limited value when the test. So this should be a check of your own work, and I encourage you to remember the pause button. Because if I do something and it gets you started, then you should pause it and see if you can finish it yourself, and then check your work here. Best use would be could do it completely yourself, and then come back and see how it compares to my key. But if you need to use it for hints, do that. I encourage you not just to copy this down, because it's not going to be as effective. All right. That being said, let's get started. Sac Republic Football Club is giving away rally towels at the season opener. As fans come in, they give away 200 towels every 30 minutes. Okay, so here you've got two different things, towels and minutes, and they're related through using a word that conveys a rate of change. Right? This is 200 towels every 30 minutes, so we're saying that this happens over and over and over again. Not just after one 30-minute period, but after every 30-minute period, there's another 200 towels. So we need to determine what x and y is here, so we can graph, what's going to be on our horizontal and what's going to be on our vertical. And as most, or hopefully all of you know, we are always putting time down here on the x-axis, because time always goes in a single direction. It never goes back in time. Other things might be able to go up and down, but time never goes up and down. It only goes one direction. So we always put it here on the x-axis. And that means that these are going to be the towels. Okay, so that means towels, this is going to be a y value. We're saying that y changes 200 by 200 as x changes every 30 minutes. So rate of change, this is something that you really have to understand as the definition of a rate of change is going to be the change in y over the change in x. Now, the last thing we might check is to say, is it going up or down? So let's read this again and say, is the number of towels going up or going down? We always know the minutes are going to be going up, right? So this is going to be 200 over 30, which simplifies to 20 over 3. In words, this means I'll say 20 fewer towels, or maybe 20 towels given away. Oh boy, that's a pretty bad away. Given away every 3 minutes. So how many towels left will they have after 2 hours? Well, we're going to need to use our table and see if we can find our graph. So they have 4,200 towels to give away. So that means when x is 0, they start with 4,200. And then every 30 minutes, they're going to give away 200. So let's go by increments of 30. You don't have to. You could go by increments of 3. But if it's going to be 20 every 3, you're going to be counting down by 20s. It's going to be a long time. So 60, 90, 120. I'm going to leave this last one blank to see if maybe we can find what the 0 is going to be. So this is going to be 4,200, and then it's 200, so it's 4,000, and then 3,800, and then 3,600, and then 3,400. And you can see I'm not going to be able to get down to 0 quite yet. But I could extend this, right? There's no reason why you couldn't just work your way down to 0. You could also say, look, from 42 to, every 90 minutes it went 600. So what if I went from 90 to 180 and go another 600 down to 3,000? And then another, so it'd be 240 minutes. And we'd go another 600, so that'd be 2,400. And you could continue to fill that out. Another way to do that would be to say, look, I've got my y-intercept. So if I've got a y-intercept, I've got 4,200. That means I've got to go from 0 here up to at least 4,200. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I went up to 4,000, that still wouldn't. So maybe if I went up to 5,000. So if this were 5,000, then that means I'd go up by 50s, right? 5,000 divided by 10. No, go up by 500s. Excuse me. I'm like, that can't be right. 2,000, 3,000, 4,000, 5,000. So we start here at 4,200, about there. And they give away 200 towels every minute. So that means at 30, 60, 90. Now I'm going to realize that I'm probably not going to get all the way down to my x-intercept. But let's just see what we can do. 30 is going to be 4,000. You can see it's a very slight slope. 60 is going to be 3,800. Let's see, the next time I get down to 3,000 is going to be 180. So 90. So, I might say, you know what, I don't like this scale. I want to do this again and say this is going to be 60. And this is going to be 3,800. So let's do that. And this is going to be 120. And that's going to be 3,400. And then this is going to be 180. And there's my 3,000. I think that's probably a better scale. So we're going to go by 60s. So this is 240, 300, 360, 420, 480. And I notice that I'm going, let's see, let's try 300, 360, 420, 480. So every time I go 60, I'm going to go 400 towels, so that's 2,000, 1,600, 1,200, 800. So by the time I get to 480, I'm down here to about 800. And that looks about right. I'll provide straight edges, rulers, or protractors of a sort for your tests, so you can really make straight lines. So then I've got 400 and 0. So finally I'm making it to my 0. 400, and this is going to be 540 and 600 minutes. So it goes all the way down to 600 minutes. There we go. Yeah. So how many towels will they have left after 2 hours? Well, that's 120. So that's 3,400. Now, this is how to do it with a table and a graph. and just the rate of change. We could also say, well, f of x is going to be 4,200 minus 20 over 3x. Right? So that means that 4,200 equals, so now we're going to go f of 120. So that's 4,200 minus 20 over 3 times 120. 20 times 120 divided by 3 is 800. So 4,200 minus 800. 800. And we get, yay, 3,400. So it checks out. So a couple ways you could go about this, right? You could just fill out the table all the way, fill out the graph very precisely, make that count, or we can build our own equation. We could say, okay, well, let's build an equation that gives us a rate of change in a y-intercept, and plug in the value for x. Number 2 here. Find the equation of the line passing through the given points. So we need to, here we're not given a word problem or scenario, it's just here's 2 points. How do we find the slope? That's the rate of change. So I've often shown you this. This is a tool that helps me not get my numbers jumbled up, because now I can do the subtraction. I say, okay, well, what's 3 minus negative 4 over 12, over negative 6, helps me not get them jumbled up, minus 12. So this is 3 plus 4 over negative 6 minus 12. So that is 7 over negative 18. Ugh. That's a terrible fraction, but it is the slope. So now we have y equals mx plus b. Well, we have an m, y equals negative 7/18 x plus b. So we need to plug in an x and a y. So negative 6 and 3 plus b. So we'll see this is let's see, 7 times, so this is going to be 21 over 18 plus b. So then I need to negative 20. So I need to add 21 over 18. So I need to go negative 6 plus 21 over 18, which simplifies to divide each side by 3. We've got 7/6. So that's going to be negative 36/6 plus 7/6. So I'm challenging you to review with fractions, because the fractions are unavoidable. But don't let that freak you out. Just take it one step at a time. 36, negative 36 plus 7 is 36 times 29. So I've got an equation of y equals 7/18 x minus 29/7. That was pretty ugly of a fraction problem. Okay, so before we get all freaked out, let's just review what steps we did. So 2 points, that gets us to the slope using y2 minus y1 over x2 minus x1. And then that goes in for m to y equals mx plus b. And what goes into the y and x is 1 point. So the x goes in for the x, and then we solve for b. So first, find the slope. Second, plug it in. Third, solve for b. That's the process. And that's if you can know that process, I guarantee you the fractions are not going to be quite this messy. And the key to any problem is not whether it's simple or looks nice. The key is, do you stick with it? So stick with this problem. Find the rate of change. All right, so rate of change. So we've got number of values in one row and one in another. Look, this is hours, so this must be x. This must be y. So we need change in y over change in x. So we could say, okay, this is going to be 5 minus 1 is what our change in x is, and 425 minus 85 is what our change in y is. So this is 340 over 4, which equals 85. Okay, so it does happen to be the same one, but notice that that is not because it necessarily is the first value. We have to calculate what is the change. All right, next one. A baker sells bread for $3 a loaf and rolls for $1 each. The baker must sell exactly $24 worth of baked goods by 5 o'clock. So we have to recognize here that we've got, look, $3 a loaf and rolls for $1 each. Notice that this is two rates, basically, right? $3 per loaf and $1 per roll. So this isn't something where we're saying there's some number, like up here, the number of towels, and it's based on the number of minutes. There's loaves and there's rolls, and they're both kind of related to each other, and there's a rate for each of them. $3 per loaf, $1 per roll. So we can see rolls here are y, and loaves here are x. So that must mean that 3x is the cost of loaves, and 1y, $1, times the number of rolls is the cost of rolls. So I've got 3x plus y, and what does it say? He must sell exactly $24. So now we have to complete the graph, and guess what? Finding the x and y intercepts are actually going to be the best way to complete the graph. This is standard form, so this is not y equals mx plus b, like we had up here, or like we used here. So usually the best way in standard form to graph is to find the intercepts. So let's say, what if y equals 0? That would make this 3x plus 0 equals 24. So if y equals 0, right, we're down here, right? We don't know where we are along here, but we know that if y equals 0, that we must be right here. This is where 0 is, y equals 0. So 3x plus 0 equals 24. 3x equals 24, therefore, divide each side by 3, x equals 8. So if x equals 8, that means the x-intercept is 8, or we could say the x-intercept is 8, 0. 8, 0, there. The y-intercept, we find the opposite. We say the y-intercept is going to be when x is not equal to 8, 6, 4, 2. It's when x is equal to 0, and then we're right there on the y axis. So that's going to make this 3 times 0 plus y equals 24. Well, 3 times 0 is 0, so we have y equals 24. So the y-intercept is 0, 24. In words, this means if he sells no loaves, he must sell 24 rolls. And here, if he sells no rolls, he must sell 8 loaves. So we've got a line there. Right? Here are 2 intercepts. There's a line. Use the graph to approximate how many loaves of bread the baker must sell if 12 rolls are sold. So if I say 12 rolls are sold, it looks like this is the point, 4, 12. 4 loaves. Right there. Okay, there's the front page. Let's do the back. Vanessa Salon and Spa charges $11 per hour for hair appointments. So immediately we have to recognize, what is it that we're given here? We are given per hour a rate of change. 11. Now, there is nothing anywhere else in this problem that's going to tell you anything other than that is the rate of change. So if you get conflicting information, you have to go back and say, wait, there's only one rate of change. That means that my equation is going to be at least that, and then I'm trying to figure out what the rest of this is. Right? There's no other, it's not, it charges $11 per hour and, $5 for each bottle of hair conditioner or something. It's not a this per this and this per this. So it's not a this x plus this x equals a certain number of numbers. What the thing we're not sure is, what's the answer? What is he charged? So a customer charge $57.50. So that's a y value for a 3.5 hour appointment. So this means when x is 3.5, y is $57.50. So we have an ordered pair of 3.5, $57.50. So it says find the y-intercept. Well, how can we find the y-intercept? This is where we have to recognize that if we're given the rate and we're given an ordered pair, then the way to find the y-intercept is using y equals mx plus b, but substituting in all the values that we have. So we have the 11 for the m, we have the x here, and we have the y here. We have an x and a y here. Oh, draw those backwards. X here and y here. So y, 57.50, that's our cost, is equal to 11 times 3.5, the x value. So $11 times 3.5 hours plus some initial fee. That's what's going to give us $57.50. So 11 times 3.5 equals 38.5 plus b. So subtracting 38.5 from both sides, 57.50 minus 38.5, 19. So here's our equation. Now, how much would a 3-hour appointment cost? Well, x is the number of hours. So let's calculate that. 11 times 3, 33, plus 19. $52. Now, this one, it gives us an equation. Teresa's salon charges based on the equation y equals 16x plus 40, where y is the total cost. So here's the total cost, and x is the number of hours for the appointment. On weekends, however, they charge an extra $25 fee. Write the new equation for the weekends. So a fee, that's one of those things that indicates this is something that's added on. It's not multiplied for every anything. So our original equation is y equals 16x plus 40. Our new equation is going to say, let's add on a $25 fee, or 25. So adding on a $25 fee is going to mean we have a plus 40 and a plus 25. So our equation is y equals 16x plus 65. On holidays, they double their total cost from the original equation. So here's the original equation. We double that. So we need to say, okay, so y equals, we're going to say 2 of those is going to be 2 of these. Right? Double this is going to make it mean that we have to have double that. So this is going to be 32x plus 80. Expensive. Okay. And now it says how much would a 3-hour appointment cost? So when we're talking about a 3-hour appointment, we are talking about the original. Okay, and I'll make sure make sure that's clear on the test. But for our review, I want you to practice comparing these two, right? We're saying we've got an equation here, we've got an equation here, let's compare. So here y equals 16 times 3 plus 40. 48 plus 40 equals 88. So which one's better? Better deal. Well, for a 3-hour appointment, it's going to be Vanessa's. Okay. Graph the inequality. 3x plus 2y is greater than 6. So first we want to draw the equal to line. Right? That's the line. What if it were an equation? So if this were 3x plus 2y equals 6, what would that look like? Well, if we put zeros in for x, right, that becomes a 0, and then we've got 2y equals 6, so y is 3. So there's our intercept. That's our y-intercept. And then if we said, well, what if y is 0, then that means this goes away, right? No longer do we have a term with y because it's 0. 2 times 0 is 0. So then I've got 3x is 6. So x must be 2. So this is 2, 0, and 0, 3. And there is my line. Oh, but wait. This is the equal to line. Now we have to say, is it dashed or solid? Well, this is the line that is all the points that are equal to. All the combinations that if you put an x and a y into this equation, you would get 6. But we are not looking for them to be equal to 6. We're looking for them to be greater than 6. So we have to dash or dot this line because the points that are actually on this line, including these intercepts, aren't actually solutions. I mean, think about this. If we had y as 3 and x is 0, and I said 2 times 3, that's 6. Right? Is 6 greater than 6? No. A number can't be greater than itself. So that's why we don't include these things. But we do have to figure out which of these is true. Where are all the true solutions? Is it all the dots on this side or all the dots on this side? So easiest way is to do a test case. And 0, 0. So we're saying, where is it shaded? Test case. 0, 0. Is 0 times 3 plus 0 times 2, so is 0 plus 0, is that greater than 6? No, it is not. So 0, 0 is not a solution, which must mean all our solutions are on this side. And I'm just going to shade it in, but that shading, remember, is all those dots, every single possible combination. That would give us greater than 6. Name a solution point. Lots of solution points. Look, here's one. Here's one. There's one. So we'll say 2, 2. Lots of them. If I said 0, 0, though, that would not be a solution point. So we'll say 0, 0. Okay, number 8. Lindsay needs a jeweler to repair her earrings. Jeweler A is offering services for an initial $125 in addition to $15 per hour. So I've got one jeweler here. We got to write her equation. So this is jeweler A. Her cost is going to be $15 per hour plus an additional $125. Jeweler B, so this is Y equals X, but I'm saying Y sub A. That's a way of saying there are two different Y's. So the second jeweler B is $12 per hour, but also an initial $140. So it's saying, when will they charge the same amount? Well, the same means when they'll be equal. So when will the amount of jeweler A be equal to the amount of jeweler B? Well, when this function is equal to that function. This is what calculates jeweler A's services cost. This is what calculates jeweler B's services cost. So if we say those two things are equal, must be equal, then we're going to find out what is the X value. The hour, when, is asking X. When will this be true? This is 3X, and I can subtract 125. These go away because there's zeros. Oops, not that one. That one goes away. This one doesn't. That one stays there and gives us 15X minus 12X equals 3X. And so we're left with 15. So X equals 5, right? Divide both sides by 3. 5 hours. All right, last one. A bookstore sells textbooks for $80 each and notebooks for $4 each. So once again, we notice that we've got an each and an each, which means that there are two variables that are multiplied. So let's look here. Which one of these is going to be notebooks and which one is going to be textbooks? Well, if textbooks are $80 each, probably here we're talking about, let's see. Well, I'm going to hold off on that. We're going to say that there are 80 textbooks and 4 notebooks. So if we say that there are textbooks, oh, here it is, T, and N. So textbooks is X and is Y. So we could say this is 40X, because textbooks are 80, and $4 for each notebook. At least. So what does this mean? You could also, by the way, you could say 80 T plus 4N. That would be fine as well, because we have an N and a T axis. So let's see. These are textbooks. These are notebooks. So, at least means what? If I said something has to be at least 800, does that mean it could be more than 800? Yeah, you could have more than 800. So this could be equal to 800 or more than 800. If you said the same thing, could you be less than $800 if to say at least? No, because if you had less than $800, that would not be at least $800. So here's our inequality. Now we need to graph. Standard form. Let's graph it this way. So highly would recommend when you have something in standard form, just put a 0 in for X, solve for Y. Put a 0 in for Y, solve for X. Find the intercepts. because it's set up that way. 0 goes in for x, then it's 80 times 0 goes away. So 4y equals 800, or is, right? So then we're going to have 4y equal 800, because this is a 0. So y is 200. So the x-intercept, when x is exactly to 0, y is 200, and that will make it equal. And that's what we want to find. We want to find our boundary line. So we know we've got a 200, 0 here, and then we've got a, the opposite is when we have 80x plus 4 times 0 equals 800. So this goes away because it's 4 times 0. So this is 80x equals 800. And we divide both sides by 80. And x equals, those cancel out, and we got x equals 10. So here's our x equals 10. So there's our boundary line. Now I drew it solid because it could be equal to those things, right? It could be 200 notebooks and 0 textbooks, and that would get them at least to $800 in merchandise. That's what this is, the at least or the equal to line. The question is, then, which side do we go on? So let's plug in 0, 0. Is 0 80 times 0 plus 4 times 0, is that greater than 800? Is 0 greater than or equal to 800? No. So it's not this point. That point is false. So we're saying these are all the possibilities of notebooks or textbooks that the bookstore has to sell. And you can say that, you can see that makes sense, that if you go lower on the notebooks below the threshold of 200, it means you're going to have to sell some textbooks before you get to that magic $800 number. All right, there's your review. Tried to go through it and explain a bunch, but I encourage you to attempt your own problems without any help, at least once before the exam, because that practice could be helpful for you. And good luck.